Okay, the big question here is, what is science? All right. So here I've got your old school memes all lined up in the scientific process. All right. You guys first have observations. You guys may come up with some questions while making observations. All right. It is then that you create your answer to the questions. All right. And that would be your hypothesis. Okay. It can be opinionated. It's something that you will eventually test in the experiment. All right. Now, you predict, create an experiment. Your experiment should test the hypothesis. And then in the end, you guys will get your results. All right. Whether they happen to correlate with the data or not. Okay. Next. Here's some common sense definitions I need you guys to know. Okay. By next week, these definitions have to be common sense. All right. Not too hard. Data. Evidence, all right? It's basically information gathered from your observations. Do understand that these observations can come from before the experiment. It can come from during or after, all right? Okay, next, inference. It's a logical explanation based on prior knowledge and or experience. Okay, that's all an inference basically is. Just logical explanation. Now, eventually, this inference may become or be used as a hypothesis. All right. Now, your hypothesis is a possible explanation for your observations. Okay, again, it is your answer. You create this answer. All right. And then, of course, during your experiment, you will test your hypothesis. And that is how science is different from possibly a history or English class for you guys, because in science you actually test your thesis, and that's why it's called a hypothesis. All right. Okay. Eventually, if your hypothesis has been correct, or no, not correct. That's not right to say. If your hypothesis has not been proven false through a very huge, broad range, it will eventually become a theory. All right. Do understand that a theory can always be proven false. For example, for about 1600 years, flat earthers had it their way. For 1600 years, the theory that the earth was flat held true. Okay, that's something to think about. That's a very, very long time for a theory to hold true. Okay, next, your independent and dependent variables. All right. Now, to help you guys remember, people use, dry mix. All right. Dry, dependent, responding, usually on the y-axis, DRY, and then mix, you're manipulated, independent, usually on the x-axis. Okay. If this confuses you, don't think about it. All right. Now, the independent variable is the variable that you control. That's why it's also called the manipulated variable. All right. So on this graph right here, you control where you take the data. So the independent variable will be in class, at work, in bed. All right. Over here, the independent variable is, the time it takes to take your recordings. Okay, now the dependent variable responds to the independent variable. Okay, so the dependent variable is dependent upon your independent variable. And that's why they have their names given. Okay, in this case, on this graph, it's how easy it is to fall asleep, the level at which. Okay, so in class, it's 100%. At work, it's about 80%. And when you're in bed, scrolling through social media, it's very hard to fall asleep according to this graph. All right. Okay, moving on. Okay, now, getting back to what is science? All right. Science, my interpretation is it's basically problem solving. Okay, that's the whole point of science. It's a process of solving problems over and over again. Now, there's another side of science. It's not just problem solving, it's also documentation. All right? And that's what my interpretation of science is. Problem solving and documentation, therefore, you can collaborate. That's what makes science so powerful. You don't just solve your problems and that's it. You solve your problems, you document it, and then that way you collaborate with everybody else. And that's what makes it so powerful, this collaboration. All right? Okay, now, the way science is documented is through what's called a lab report, and it's usually separated into 5 main parts. You got your introduction, materials and methods, your data, analysis, and then your conclusion. Now, we're going to go into this, all right, next time. Okay, for the end of this time, I do have to teach you guys how to create what's called your null hypothesis and your alternate hypothesis, all right? This is the way researchers create their hypothesis. This is the way doctors, PhDs create their hypothesis. If you guys are going to college, this is how most upper-level college classes write their hypothesis, okay? No more of this if, then, and because anymore. You guys aren't kids anymore. All right, this is how grown-ups do things, and this is how I'm going to expect you guys to write a hypothesis. Okay. Now, the easiest way to do this is to first create your alternate hypothesis. Okay, and it's funny that you always write your alternate hypothesis below the null hypothesis. The reason for that is because your alternate hypothesis shows change, shows results, shows what you want. Okay, in that case, if you put this first, it shows a biasness, and that's what science really does not want. Science does not want bias. Okay, now to prevent bias, you write your alternate hypothesis below the null hypothesis. Okay, now the easiest way to create an alternate and null is to first skip a space for the null, write your alternate hypothesis first. Okay, basically your alternate hypothesis is the exact same hypothesis that you guys have been creating since your first day in science class. Okay, this is the if, then, and because. All right. Okay, do understand that your alternate hypothesis has to show that there is a change or there is a correlation in the data. Now, once you finish writing your alternate hypothesis, you then go back up to the empty space and you write your null hypothesis. Do understand that the null hypothesis shows no change or no correlation in the data. All right. Now, if you accept your null hypothesis, it's almost as if you're rejecting the alternate. Okay, so in college, in research, you never reject a hypothesis. It's either you accept your alternate or you accept your null. All right. Okay, I'm going to give you guys a few examples now. Okay, remember, science is just problem solving. This process of problem solving can be used in any situation. Okay, in this case, imagine you see someone named Kylie eating a pizza. Okay, now Kylie's eating a pizza and she starts smiling. All right, now you've got these two sets of observations. Kylie's eating a pizza and she's smiling. Okay, now because she's smiling, the inference I would come up with is that, you know, it tastes good. All right, now according to these observations and this question, all right, you create your alternate hypothesis first. Okay, in this case, research question is, what does it taste like? All right, because imagine if you've never seen a pizza before and you've never eaten a pizza before. All you know is that Kylie is eating a pizza and she's smiling. Okay, so create your alternate first, skip a space for the null, write your alternate. Okay, because Kylie is smiling, the pizza tastes good. That would be your alternate hypothesis. All right, now you write your null hypothesis. Due to the smile, the pizza does not taste good. Okay, it's the opposite. Do understand that it has to encompass all the possibilities, all right, if you do not accept the pizza is good. Now, some of you may have been like, why is the null hypothesis not the pizza tastes bad? All right, well, here's the answer. Basically, just because it doesn't taste good does not mean it's going to be bad. All right, it could be average. It could be a little above average. It could be almost good. You know, there's a whole bunch of different possibilities that it does not have to be bad. All right. Okay, now in this scenario, once you guys have your alternate or your null hypothesis, you create an experiment. Okay. Experiment here is you go and buy a slice of pizza and you eat it. Okay. Now, data, the taste in your mouth, analysis, conclusion. Okay. How does the pizza taste to you? All right. Now, here's another part of science. You always end up with a refined hypothesis. That way, you continue to solve more and more problems. All right. And then once you guys document these problems through a scientific journal in a lab report, all right, then once it's documented, you guys can share and collaborate with people from around the world. Okay, again, this is why science is such a powerful tool. Okay, now, I assume since you guys are new to the alternate and null hypothesis format, you guys may have a few more questions. Okay, another easy example that I like to use is, you know, you're looking at a table. If the table is black, all right, so that's a problem. Okay, that's your research question. What color is the table? Okay, now, because it looks black to you, your alternate hypothesis will be the table is black. All right, now the null hypothesis will be the table is not black. All right, a lot of people might be thinking, why is the table not white? Okay, again, these two statements, your alternate and null, they have to encompass all of the possibilities. Okay, remember, just because the table is not black, it doesn't mean it's white. It could be pink, green, purple, polka dots, whatever you guys want it to be. All right. Okay, moving on. Okay, now, a few important things you guys have to consider. All right. The hypothesis, you guys can always revise at any point in the scientific process. Okay, if at some point in the process, even if you're not at the end of the process, if you notice some very drastic results, for example, you can always just revise or alter your hypothesis. All right. And of course, even if you reach the end of the scientific process, after you document, you always continue to revise your hypothesis. Remember, that way, more and more problems can get solved. Okay, experiments and testing your hypothesis. Okay, for example, here's another thing to consider. It is not always possible to create an experiment, all right? During these situations, all you can do is observe and take down and jot down your observations. Okay? An example here can be, let's see. For example, you want to solve problems with wild animals. Okay? Or you research wild animals. Okay? You want to see how they behave. Now, you cannot catch a wild animal and expect it to behave the same way when in captivity. All right. Therefore, in this case, it is impossible to create an experiment. Therefore, researchers, scientists that work on animals, wild animals, researchers that work on the environment, okay, all they do is go out and survey. All they do is go out and take further observations. All right. Okay, and that brings this session to a close. Make sure you guys to comment and subscribe. Now I'm just playing. Make sure to write down any comments if you guys have any questions. All right.